Hello everyone, and welcome to the Lovebyte 2025 seminar, Making Tiny Music with the 12-tone scale. As the name suggests, this seminar is about making music for tiny intros, specifically for audio systems that are naturally tuned to have 12 tones per octave, with the pitch of a note given as an integer. A particularly noteworthy example of such an audio system is MIDI, which is popular not only in DOS 256-byte intros but also on Windows 1 case. Another example is the Decade audio system, which I will use for today's demonstrations because it is easy to make visualizations with it, giving you a better visual idea of what's happening behind the equations I'll be discussing. Even in arbitrary JavaScript or bytebit or shader music, since you have a cheap power function available, it is fairly easy to generate the 12-tone equal temperament tuning with something like 2 to the power of n divided by 12. Some of the tricks I will teach you today might motivate you to use this method even in shader music or JavaScript. In this kind of audio system, the notes are numbered so that one note is given the number of 0, let's say a low C here, and then the notes go up by semitones. So C sharp is given note number 1, D is 2, D sharp is 3, and so on until you make it up to the note number 12, which is the next C one octave above, and it repeats over and over again. So in this kind of system, somewhere in your code, you have a function which I call here the function called note, and the task of that function is to compute what note we should be playing at any given time. In this case, it takes the time as a parameter and should return what note is being played. And since Decade naturally runs at 60 Hz, T here is increasing by 60 every second. In actual size coding, of course, you would be unlikely to use any actual function call for this as all equations would be in line, but here I kept it as a separate function, so it will be easier for you to follow what's going on. In a 4K intro, you'd probably use some kind of heavily data-driven approach, such as order list and pattern list, like in the tracker style, but in tiny intros, that's probably too much. We can use some data, but we'd prefer use generative equations or equations combined with some minimal amount of data. So let's make an equation. For example, t shifted right by 4, so t divided by 16, modulo 12. So what this does is it hits all the 12 notes of one octave and then returns back to note number 0. Run it, and it's exactly what we get. Now, it works, but looping the entire chromatic scale is not harmonically very pleasing, so let's try to add some decent harmonic structure to the song. Let's try to play the C major chord. Now, to play chords, we need more channels. TK80 supports up to 4 channels, numbered 0 to 3, and this code passes the channel to the note function as a second parameter, the parameter chan here. So then we need to figure out the note numbers of a C major chord. So the note numbers for a C major chord would be 0, 4, and 7. But since we have 4 channels, that's only 3 channels. So if we have 4 channels, we could make the 4th channel play C one octave up. So note number 12 there. So let's use a table for that. So let's call a table called pat and 0, 4, 7, and 12. And then we're gonna play based on the channel, we're gonna pick one of the elements for here. So we're gonna say chan, and because the Lua tables are starting indexing from 1, we add 1 to the channel, and we get a C major chord. Now, that's just one chord, but we'd like to make actual chord progressions in these songs. Since we have already used our precious bytes for that lookup table of a C major chord, can we reuse that for other major chords? Certainly. We can make an F major chord from the C major chord just by shifting our hands to the right on the keys by adding 5 to all the note numbers. And with a similar logic, we can do it with the G major chord. In this card here, the chord progression is determined by a function called chord. And so we will make the chord function return 0, 5, or 7, depending on time t. Like so, let's make a table. And then we return prog, let's say time shifted right by 7. Let's take a modulo of the length of the table plus 1 because the Lua table start indexing from 1. Now, there's another function called mapping here, and the purpose of the mapping is now to combine the values returned by the chord function and then the function, the note function, the N and C here, but in this case we just add them up. So we'll start later on playing with the mapping function, but for now we just add these two values up. And what we get is this. So when the chord function returns 0, this is the value returned by the chord function. We are sitting at the 1 chord, now we are at the 4 chord, and now we are at the 5 chord. So C major, and then we go to F major, and then we go to G major. Okay. This totally works, by the way, with minor chords too. So for minor chords, we would just drop down the major third by a half a step. So now it becomes a minor third. And we get minor 1, minor 4, and minor 5 chord progression, or C minor, F minor, G minor. Great. So now let's start to work towards having melodies, and we'll start that by just adding different arpeggiation to the chords. So instead of picking the note to be played based on the channel, we're now going to pick it based on the time. So we could, for example, say time shifted right by 5. And then we have to take, again, a modulo of the length of the pattern. And now we get this minor chord progression where we are playing minor 1, arpeggiating the minor 1 chord, and then we are arpeggiating the minor 4 chord, and then we are arpeggiating the minor 5 chord. Okay, but now all the channels were doing the same thing. So let's make the channels do slightly different things. For example, we could make the channels play at different speeds, the arpeggiation. So we multiply the time by the channel number. And what this does is that actually the channel number 0 is never advancing from 0. So this gives t times 0 will be always 0. So it will actually be playing always the root note of the chord, but then the rest of the channels are playing at different speeds. So what that does is okay, very nice, but they are all playing the same octave. So let's also move the other channels. In the mapping function, we also have the channel available, so we can move each channel up by octave. So channel number 1 is up by 1 octave, and channel number 2 is up by 2 octaves, and channel number 3 is up by 3 octaves. That was a minor chord progression. You can clearly hear it coming through the minor quality of the chords, even if they're arpeggiated, but we could go back to majors. So we'd like to make it harmonically slightly more complex, but there's a problem now. Firstly, because of the way we are generating the different chords, since we are using the same pattern for all chords, we can only generate For example, in this case, if we have a major chord, then we can only generate major chords. And in the diatonic scale, there are only three major chords. In the key of C, these major chords are C, F, and G, the 1 chord, 4 chord, and 5 chord. If we stick to the system we have here, we now must go out of key. It's not necessarily a bad thing, but you have to be a bit careful with that. Otherwise, you're going to sound kind of messy. So what out of key major chords might be useful? The first one that comes to my mind is adding a secondary dominant, a D major, which is the dominant of G. So we could go, for example, a progression of 0, 5, 2, and 7. So this would be C major, F major, D major, G major. Okay? What do we... So totally works because even if the D major is out of key, it maybe sounds a little spicy when we first hear it, but then as it drops to G major, it makes complete sense. Okay, you could go crazy and make a full circle of fifths chord progression or whatever. Now, other kind of chords that I found useful if you only have majors, for example, all the borrowed chords from the parallel C minor key, so flat 3, flat 6, and flat 7 chords. So for example, flat 3 is great to throw on the way to 4 chords. So flat 3 would be the 3 over here. So 1 chord, flat 3, 4 chord, and back to 1 chord. So starting the numbering from C, starting the numbering from E flat, and starting the numbering from F and back to C. And what we get is... We could also do like in the key of E major, we could drop down two whole steps into C chord and then come to D chord, D major chord, and back to E major chord. So E major, C major, D major, E major. This is something like called the Super Mario cadence because this chord progression was used in the in the fanfare that is played when Super Mario reaches the castle. Okay, so last one. Cool sounds. These kinda all sound very happy, but you can squeeze out a little bit more ominous tones out of major chords still. So in the key of C, we play C major, but then we raise half a step to go into D flat major. So we get something like... Okay, so this is actually suggest a Phrygian dominant sound to invoke that desert feeling. Okay, so we can do some kind of chord progressions with this system, but there's two problems now. First problem is that it's actually very hard to make good chord progression with only major chords, and even more difficult with only minor chords. So we would like to at least throw in an occasional minor chord, even if we are mostly doing major chords. The second problem is that the voice leading is not very smooth. So we are always, if we are playing chords, we are always playing them at the root position. We'll first deal with the problem number one, and then later on we'll deal with the problem number two. The solution to problem number one is this. Imagine a piano with all the black keys removed and the white keys would be numbered in the same way as we numbered our keys before. That is, we start with the low C and give it the number 0 and then give each key a consecutive number. You could say that the white keys form a heptatonic scale, where every octave has 7 tones, whereas all the keys of a piano with all the black keys included would form a chromatic scale. Every octave has 12 tones. So how do we map from these heptatonic scale note numbers to the chromatic scale note numbers? And the answer is what I call the roller trick. And I call it the roller trick because I learned it from Rolla, and this is a different roller trick than the trick to find the pixel coordinates on DOS. So there's an equation, n times 12 divided by 7, and this slashes on Lua is an integer division, so integer division by 7. And what this does, it maps the heptatonic scale, the 7-tone scale, into the chromatic scale, the 12-tone scale. So this is the reason I have the mapping function in the code. I'll add this code there. So we're going to go to the mapping function, and then we're going to multiply the note numbers and with the values written by the chord function, multiply that by 12 and divide by 7. And let's see what we get. Let's turn off the chord progression for a while, and let's see what we get. So what scale is this? Well, it turns out this is actually a C Locrian. So if we have C and we have E flat, F, G flat, A flat, B flat, C. So these notes, they form the Locrian mode. But if we would start the scale from the first note, so we would have D flat, E flat, F, G flat, A flat, B flat, C, and D flat. This would be a D flat major scale. Now what we have to do is just drop that down by a semitone to get back into a C major scale. What I mean here is that we need to add one because we start from the D flat and then we drop that down by one semitone to get back to C major scale. And what we get is this. Now we have a mapping function that has effectively removed all the black keys from our piano. Okay, so what now? We can, for example, do the notes number 0, 2, and 4. So this would be like a C, and this would be a E, and this would be a G, and now C 1 octave up, and we get not much improvement here, but now we can start doing something fun. For example, we can start from D, and that will give us a minor chord. So we can go D minor, D minor, C major, C major. Okay, we can, let's say, that doesn't suggest anything particular scale. I mean, it's a bit ambiguous. Are we in Aeolian or Dorian mode right here? But we could do like throw a chord number 4 here, and that corresponds actually to the major 4 chord in the Dorian mode. So let's see what it sounds like. Now, the beauty of this is that now we can start adding passing notes. So, for example, instead of having only the notes number 2, 4, and 7 here, we could add, let's say, 4, 3, 2, and we go, I don't know, like, let's go 4. Okay, so maybe we slow down the arpeggio a little bit. Okay, particularly great, but starting to get somewhere. We get some kind of clear chord progressions going on here, and we are not hitting any out of key notes ever. We could make, I don't know, like let's try different patterns here. So so the critical thing when making these patterns is that you have to hit the note numbers 0, 2, and 4 to sort of imply the underlying chord, because those are the chord notes. But then you are free to add more of the passing tones in different parts of these chord progressions um, to give them a bit of a color. Pretty nice. So far we have solved the problem number one, which is that we can now have minor chords and we can have major chords, and our melodies always stay in some key. But remember that we had also the second problem, which was that the voice leading is not smooth. So the chords are always played at the root position. So let me explain what I mean by that, and let's comment away the melody for a while. And let's go back to playing plain chords. So for example, pat2 equal to, so a basic chord shape. And we're just going to return that based on the channel. Not moving things up by octaves anymore, so they all be in the same octave. And let's see what we get. Okay, so D minor chord, C major chord, back to D minor chord. So far so good. I mean, the voice leading is pretty smooth. We are moving up by just by whole steps. But then this is the problem. So now when we have the 4 chord here, the whole thing jumps a lot. So the voice leading from the C major chord to the G major chord was not very smooth, or nor it will be very smooth when we go from this G major into back to D minor here. So what can we do? Well, let's focus on just on the, let's just focus on the G major chord, the 4 chord here. So how could we sort of invert this so that we would start the chord at D? So how can we make so-called the second inversion of this chord? So we would want to play the chord so that this, we would have a D, G, and B, and maybe a high D over there. What we're going to do is that we're going to remove more keys from our piano, and we're going to remove one key between the fifth and then the octave. So it can be sixth or it can be the seventh, but we're going to remove one key there. So let me show what I mean. We're going to again do this kind of n times 7 divided by 6. And what this does is that, notice that now we have the note numbers 0, 1, 2, 3, 4, 5, but the octave is now 6. So let's fix that pattern so that we are actually playing the G major chord now here. So now the octave has a note number 6, and so now we are playing the G major chord. And now the magic is that if we subtract any number from n, which is a multiple of 2. So for example, if we subtract 2 from here, what we get is the second inversion of the G major chord. So we are starting the G major chord from D, G, B, and D 1 octave up. And we don't want to do this inversion always. we just wanted to do when the C is a large number, because the C being a large number, we have shifted our hands a lot to the right. But then, for example, when we could do something like C divided by 2, so the integer division flooring down, and then multiply by 2. So any number, a multiple of 2 works here. And now let's see what we would get, for example, for a chord progression of, let's say, D, C, and this should be like a F major and back to D. So D, C. Now we have an F major, but it's in its second inversion, and the voice leading is much more smooth between the F major and then the D minor. And now we can bring back the melody. So for example, let's have 2 patterns. So for channels, let's say for the first 3 channels, we're just going to play the chords. So that's going to be from the path 2, which is has the chords. And for the 4th channel, we're just going to play some melody. And we're going to move that up by 2 octaves. 12 is now 2 octaves, so that the melody is playing higher than the chords. So let's see what we get. So let's let's play the melody slightly faster. So you can hear that this 3 chord here, this F major chord, there's a like a much more smoother voice leading in the chords below, and also the melody is not. I mean, the melody does have these jumps, but it kind of quite very subtly changes to so that the chord tones map into any chord tones. So with that, I think we're about done today, and the only thing that is remaining that I have a bunch of homework for you. And the homework are try the roller trick with times 12 divided by 5. So what scale is this, and what are the 2 most useful modes of this scale? Find the smallest equation for a harmonic minor scale. Now this is an open problem. I actually don't know what is the smallest equation for the harmonic minor scale, but if you can do harmonic minor, we can obviously do some of the modes of harmonic minor, and Phrygian dominant is one of the modes of harmonic minor, so we can make cool desert pyramid intros with this kind of scale. The last homework is you should try the roller trick with the chord function returning non-integer values. So what useful chords you find? So hint, this means that you don't necessarily have to be always in some key. You can go slightly out of key even with the roller trick. So with that, I thank you for your attention, and I hope you enjoy your Lovebyte.